Reactive extensions, or RxJS, is a library for reactive programming using the observable pattern. That might be all new to you, because this presentation is meant for people completely new to RxJS and might be sitting like this right now, overwhelmed by what this library is. But do not worry, I will teach you everything about the basics of RxJS in this video. RxJS in a nutshell. This is just to give you a quick overview over what it is before we go into the deeper details. It is the library for event-driven programming, and it's the best way to work with async data, at least in my opinion. And we're using something called the observer pattern, if you're familiar with that. But no worries, if you're not, I'm going to teach it to you. And here we can manipulate data before it arrives in a functional way. You can think of RxJS as Lodash for events, if you're familiar with Lodash. It's a utility library that provides a lot of the features that JavaScript now has but didn't have in the past. Okay, so everything starts with getting some data. What do I mean? You've probably not thought about it like this before, but usually when you're getting something from a function, you're pulling the response. You are saying when you want the function to execute and when you want the data returned. There are no async await inside there. There are no waits. You get the result instantly. And that's good, but what if you want more than one value from one function? You might not have known this, but you have something called iterators and generators that allow you to return multiple values one after each other. This is of course really useful in some situations, but what if you don't have control over when the data is returned? What if you want to be notified when the data is ready? The first example is promise. A promise can resolve in the future to either true or false. Like in this example, it's resolved to true after 1 second. And that's good. That means we can take the promise.then and console log when it's returned. Amazing. But the problem here is that once it's resolved to true or false, it's completed. You cannot get another value on a single promise. But there's a problem. We have a missing cell in our table. We have no way of pushing multiple values to you as they arrive. For example, a WebSocket connection sending out a lot of messages. Well, you might have already guessed it, but it's observables. So now we're entering the amazing world of RxJS, and I'm going to show you the basics of what RxJS is and how you can use it in your web applications. The core concept is subscribing to future data that you do not know when will be returned to you, but you want to execute some code when it happens. It all starts with data sources, like from event, which allows you to wrap around already existing events like window, mouse move, and your favorite search box, .key down. Another data source is a timer that executes each second, or in Angular, http.get. You have also, for example, WebSocket, or a simple list of items that's returned one after another, or you can even wrap from a promise to an observable data source, and many, many more. And what do you do with these data sources? You subscribe to them. That is a callback for each new value, so you can handle them independently. And there's a total of 3 different events that can happen on a subscribe. That is the next handler, that's called each time a new value is sent, the error handler that executes each time there's an error, and the complete handler that completes when there's no more data. Let's look at a practical example for a moment. Imagine that you have a search box and you want to execute some code each time the user has typed something there. For example, with the key up event. Then you can get the element by ID as normal and then create a from event data source with the search box and the key down event, which you then subscribe to so that each time a key is pressed, you will get a new event. Let's look at another practical example, the off handler, which allows you to send in several values separated by comma, which will be sent as separate next events. You will here get 42 and then 200 as a separate event. But you can also create your own observable. Here we create a new observable, which you inside can return values as you want with the .next handler, which is also returned to the subscribe as the example above. And the important thing to know is that each subscription is independent of each other, which means that if you have a source of, for example, 2 values, each subscription will get those two values separately and independently of each other. And nothing happens until someone subscribes. For example, if you have a backend server which you try to do a HTTP request against, nothing will happen until you append the .subscribe, which actually executes the function in many of the same ways as if you omit the last two parentheses on a function in JavaScript. And this is known as cold versus hot observables. And also, if you're subscribing to something, you probably want to unsubscribe from it in the future as well. And that is done very easily, as each time you subscribe to something, you will be returned a subscription object which you can do .unsubscribe against. Let's look at a few more complete examples. For example, with off, as seen before, you can get a series of values independently as separate events, but you can also do it with from, which takes, for example, an array, which does the same thing. Or you can use from event, window.mouseMove, get event each time the user moves their mouse. And you can even wrap around a WebSocket, so that each time a message is sent over the WebSocket, you will get a new next event. I can even have a timer with just one line of code that sends you a new event each second or whatever interval you're specifying. And you can even create your own. Do not look too closely at the code, because it does exactly the same thing as the timer above. You can just write it out yourself. But you will generally see that it's a lot easier to just use the built-in functions provided by RxJS instead of writing it on your own all the time. But what if you want to change the data before it arrives? Before we do that, we need to talk about streams and the time axis. This is more or less an observable data stream over time. We're starting on the left side with the value 1 coming in, and after some more time 2, and even more time passes 3, and then we have the end on the right side. That means we can talk about what we can do in between our data source and our subscription, where we can have a series of operators in our pipe. Okay, that's a lot of fancy words. Let's look at an example. For example, map. On the top, we have the incoming stream, where 1 is sent, which is sent through the map function, which just takes the input and multiply it by 10 and return that. So 1 becomes 10, 2 becomes 20, and so on. Another example is filter, which allows you to specify which values are allowed to pass on. For example, you have 2 coming in. That is unfortunately not bigger than 10, so it's stopped or destroyed. But 30 is, so it's allowed, and 22 is as well, but 5 is not, so it's stopped. Or you have, for example, skip, which allows you to say that skip, for example, the 2 first events that's arriving, or take only the 2 first events. Or you have delay that just pushes the events forward in time by, for example, 1 second. Then we have throttle time, which limits the amount of events that are allowed to pass through each time that you specify, for example 50 milliseconds, which in this example allows A to pass. Then there's a lockdown period of 50 milliseconds, which disallows X and Y from passing, and then allows B because enough time has elapsed since the A event, and so forth. And then if you combine the last 2 operators, you will have something called debounce time. This operator requires it to be silent for a given amount of time before it allows the last event to pass through. For example, with 1, let's say there's a debounce time of 1 second. It then waits for at least 1 second to check that there's no new events, and then it allows it to pass through. But when we get the event 2, there's something different happening, because before that debounce time has elapsed, another event arrives, 3, and then 4 and 5, and all the events before 5 gets dropped because a new event replaced it. And then, after a second, because nothing else has arrived, 5 is allowed to pass. And then we have something called switch map, which allows you to switch from one observable to another, from a timer to a HTTP call, and so forth. But this is RxJS on a new level, and I'm not going to cover this in this video. And of course, you need error handling as well. For example, you have retry, which allows you to specify an amount of times it should retry automatically, like with a failed backend response. So you can say retry the backend 2 times before you actually crash. And you can also catch the error and return something else. For example, switch from server A to server B, because your server B is the backup server. And as a side note, I want to mention that Angular's HTTP client is built upon RxJS, which means that get, post, everything is observable, and you can pipe and subscribe on them. and there's no need to unsubscribe after a response because it automatically unsubscribes. Okay, let's get back to the search box for a minute. This is the same search box, where you want to do something after the user has typed a key. But the problem here is that each time they type a key, you do a HTTP request, which sounds fine until they start typing fast and you fire off hundreds of HTTP requests to the backend at the same time. And the backend is overwhelmed. How do we solve this? This can be easily done with debounce time. If you set debounce time of, for example, half a second, that means that the user has to stop typing for half a second before the last key down event is allowed to pass and all earlier events are dropped. Okay, let's look at a few other examples of operators and observables. First off, what if you want to create a timer that executes each second for 5 seconds? That sounds like a complicated problem until you just use the interval timer and the take 5, and then you're good to go. And what if you want to execute some code after there's been no mouse movement for 1 second? This might be complicated as well until you remember the debounce time. This is really useful if you want to, for example, save the application in a drawing application once there's been no changes to the drawing in like 1 second. And what if you want to map the server response before passing it on? This might be useful if several components need the same data, but you don't want to duplicate the transformation of the data into the format that you want. And here you can do, for example, against the HTTP request, pipe it to a map that maps it from a string to a date so that every consumer or subscriber will get it already as a date. And what if you have a WebSocket that's sending out a lot of messages that you want to plot in a graph, for example, but you only want a few of the messages and only one a second? Now you can start to combine operators, like filter down to the one message you want, map down to the part of the data you want, and throttle time, or give me maximum one event per, in this example, second. And then you can use it directly, show it in the graph or something. But then someone asks, what if you want to control when the data is emitted? Then we need to enter the world of the subject. This is a so-called active observable, which is shared by default and is multicasted to all subscribers. That's a lot of fancy words. Let's look at a few examples. Here we have a normal observable being created with new observable where you're nexting from inside the callback function and then subscribing to it. Subject is different where you're creating an object which you can next directly on, and the values being returned is shared by all subscribers, which means the topmost subscription here gets both values because it subscribes before all are sent, but the bottom subscription only gets the values sent after the subscription was set up. And this works really similar to how event emitters in Angular work. And here you can see them side by side, where the old-fashioned observable has the next handler inside, but the subject can next directly on its object. But you should try to favor observables over subjects when possible, because it leads to cleaner code, but there's a lot of times when subjects are the only way to solve the problem. And we have a variation of the subject, which is called behavior subject, with just one change. It has a default value. And here we can see a behavior subject that starts with a default value Kim, which is returned on the first subscription. And since the first subscription is set up before the next value Tom is emitted, it also gets that value. But the final subscription only gets the last value, the current value of the behavior subject. A good quote from the documentation sums this up really nicely with a stream of birthdays is a subject, but a stream of a person's age would be a behavior subject. And of course there's a few other subjects like replay subject and async subjects with their own small tweaks, but I'm not going to cover them here today. And remember to always unsubscribe, especially in a single page application, usually when you unmount or destroy the component. And I want to say that you should not overuse RxJS because this is a powerful library, but only when it's used correctly. And that is more or less when it provides a clear benefit, like with events, user actions, and HTTP calls. And I want to also say that this might actually become a part of JavaScript in the future. There's an ongoing proposal to merge it into the ECMAScript standard as ECMAScript observable. And this has been Reactive Extensions RxJS. I hope you will love this library just as much as I do.